Alright. A plus B quantity squared equals A squared plus B squared. True or false?
True.
Ah. At least one of you is wrong. It's false? No, but that's closer.
A squared plus 2AB.
A plus B squared, if you distribute that out, you get A squared plus 2AB plus B squared. So this is false. Square root of A plus B equals square root of A plus square root of B. True or false?
True.
True?
Yes.
False? Just to be different? All right. Tell me two numbers that you like for A and B. Pick two of your favorite numbers. 1 and 2. So is the square root of 1 plus 2 equal to the square root of 1 plus the square root of 2? True or false? Square root of 3 is not equal to 1 plus the square root of 2. So square root of A plus B equals square root of A plus square root of B. True or false? False. ln of A plus B equals ln A plus ln B. True or false? False. Why is it false? Because all the other ones are false. And what do you know about addition and ln's? It doesn't work. In fact, I'm told back in Math1412 you learned that ln of A times B is ln A plus ln B. Correct? Sure. Yeah, I remember that. Oops. True or false? Cosine of A plus B equals cosine of A plus cosine of B. False. Why false? Well, because everything else has been false, it seems as though this one should be false too, right? Well, let's try it. Give me two angles that you like. 60 and 30 are nice degrees. All right, so cosine of 60 degrees plus 30 degrees, does that equal cosine of 60 degrees plus cosine of 30 degrees? Well, what's 60 plus 30? And cosine of 90 degrees. You should know that, that's right.
90 degrees would be up, which is pi over 2. The cosine of pi over 2.
So it's 0, correct, that's 0. Cosine of 60 degrees. I'm going to have to start standing by the door again, I see. Cosine of 60 degrees is not root 3 over 2. It's 1/2. Cosine of 30 degrees. Now it's square root of 3 over 2. So are those equal? No. In fact, when it does work, it doesn't work very often, if f of A plus B happens to equal f of A plus f of B, then f of x is called a linear transformation. All of these things that I wrote up here, squaring, square roots, ln, cosine, are any of those things what you would call linear? No? No, none of those things are linear, are they? So the only time this works very, very rarely if I were to give you f of x equals 3x. Then f of a plus b would be 3 times a plus b. And what could you do with 3 times a plus b?
3a plus 3b.
There's your distributive property. 3a plus 3b. That's f of a plus f of b. So there's an example where that works. What kind of special equation is this for a linear transformation to work?
A linear equation.
It's a linear equation. So the only time you get a linear transformation is when you have a linear equation. All these other equations that I wrote down, none of them are linear, so that property is not going to work. How about sine? Is it going to work for sine? Is sine of a plus b going to be sine of a plus sine of b? No, I'm not going to look for that either. That one's definitely not linear either. All right, so we're going to have. You think cosine is nicer than sine? Why is cosine nicer than sine? Seems to be easier than sine. It's prettier phonetically.
Yeah. Actually, everybody writes sine as I don't know if that's how it's proper. Yeah.
All right. Well, what we are going to have in this section is 1, 2, 3, 4, 5, 6 new identities. Yay, new identities. All right, so do you remember? I gave you a list of stuff you had to memorize. And then I told you if you had other stuff to memorize, I would add that to the list. I am not adding this to the list of stuff you need to memorize. So when you go to take your next test, I will give you a formula sheet, and it will have those on them. You do not have to memorize those. I know, I'm old softy today, aren't I? The important thing to recognize is sine of s plus t. You don't just get to do sine s and sine t and then add them together. It doesn't work. So the formula is sine of s plus t. You have to do the sine of s and then the cosine of t, and then add the cosine of s and the sine of t.
Why?
All right, why? That's a wonderful question. If you want to know the answer why, you see right down here it starts with proof of addition formula for cosine.
That's not proof of addition formula for cosine.
Well, it's here. It shows up. But, so if you really want to know why these are true, you can look in your book. You don't really want to know why. You're just going to believe me. That's a good idea. But well, I'll tell you what happens. You draw the picture correctly. Here's the picture that you draw. And then you recognize that this distance has to be exactly the same as that distance. So you use the distance formula for the one and the distance formula for the other, and you do some fancy math work, and it all works out. Okay? So these formulas, these 1, 2, 3, 4, 5, 6 formulas, really turn out to be just a special case of the distance formula. Now again, I'm not going to go why. I'm not going to go through why they're all true. But what I want you to recognize is it's not easy. Cosine of s plus t, you take cosine s, cosine t, minus sine s, sine t. And that's how these work. Okay? Questions on that? All right, so now I'm going to ask you a question. What's the cosine of 75 degrees? And then you can use your calculator and you can give me a decimal. I don't want the decimal. I want a nice exact answer with square roots written in it and stuff. 75 degrees, is that one of the angles that's on the chart that you've memorized?
Nope.
No. Can you write 75 degrees using angles in that chart that you memorized?
Possibly.
Possibly. All right. So how can you write 75 degrees?
Cosine of 15.
All right, I could use 90 minus 15. That's true. 90 I know all about. Do I know anything about 15 degrees? Is that one of the ones in the chart that I memorized? No, so 15 is not a good one to use. How about 45 and 30? Are 45 and 30 angles on that chart that I've memorized? Yes, that's what we are. All right, so now I look up the formula. It says cosine of two angles added together. I do cosine, cosine, minus sine, sine. All right, so I write that down. So this is going to be cosine 45 degrees, cosine 30 degrees. Equals cosine, cosine, minus sine, sine. Sine 45 degrees, sine 30 degrees. And now I look at the chart. I don't need to look at it. I've memorized it. Cosine of 45 degrees. Root 2 over 2. Cosine of 30 degrees. Root 3 over 2. Minus sine of 45 degrees. Root 2 over 2. Sine of 30 degrees. So it looks like my final answer is square root of 6 minus square root of 2 over 4. You know in radians better? Okay. Excellent. Did you know in radians better? What's the sine of pi over 12?
One of the ones that we learned.
That's not one of the ones that we've learned. That's right. So what we need to do is we need to write pi over 12 using the angles that we know. What's that? It could be we have formulas where we add and we have formulas where we subtract. So it has to be addition or subtraction. Pi over 6 plus pi over 6 is not pi over 12. It's 2 pi over 6. To add fractions, you add the tops and the bottoms of them.
Oh, pi over 3 and pi over 4.
Pi over 3 and pi over 4. Those will have a common denominator of 12, won't they? So which order do I put it in? Am I adding? Am I subtracting?
No, you're not. Wait, no, you have to do 4 first. Pi over 4 because, no, wait, hold on. Pi over 3 first. You're going to do pi over 3 first because you'll multiply the bottom by 4 to get 4 on the top and then the top by 3. So that 4 minus 3 is 1. Nah.
All right, I finally agree with Brandon. That pi over 12 can be written as pi over 3 minus pi over 4. Because when I get the common denominator, this would be 4 pi over 12. This one would be 3 pi over 12, and I subtract, I would get pi over 12. All right, so now I got to look at the formula for sine. If I have sine and I have a minus in the middle, I do sine of one, cosine of the other, minus, and then I switch them. All right, so it's sine of the first one, cosine of the second one. So it's sine of pi over 3, cosine pi over 4.
Will we get questions in radian on WebAssign?
Oh, do you think you'll get questions in radian on WebAssign? I'm quite sure you'll get questions in radians on WebAssign. I'm very confident you'll get degrees and radians. You'll get both. And then it had a minus here. And then I switch it. So I do cosine of the first one, cosine of pi over 3, sine of pi over 4. All right, so once again, now I look at the other table that I've memorized, the one where everything's in radians, and I know that the sine of pi over 3 is Oh, I hear some dissension.
Hold on.
I heard a root 3 over 2. I heard a 1/2.
1, 0.
He sounds very confident with this. It's root 3 over 2. Oh, she's changed her mind? All right, we'll go with it then. Root 3 over 2. Cosine of pi over 4.
Square root of 2 over 2.
Square root of 2 over 2. Minus cosine of pi over 3. 1/2. Sine of pi over 4.
Square root of 2 over 2. No, that one.
Square root of 2 over 2. So we end up with square root of 6 minus square root of 2 all over 4. It looks very familiar. In fact, it looked exactly the same as what we got before.
And they all know how much the same.
Will they always all be the same answer? No. Why did these two happen to turn out to be exactly the same?
Because the sine of pi over 12 equals cosine of 7.
Because 75 degrees in pi over 12 happen to be complementary angles, and the cosine of one angle and the sine of the complementary angle happen to be the same. Now, are they going to be similar? Yes. I mean, we're always going to be using these special angles that we know, so we're going to end up with a lot of square root of 3 over 2s and a lot of square root of 2 over 2s and a lot of 1/2. So will we get a lot of answers that look very, very similar? Yes, but will they always be exactly the same? No.
Here's a laminator.
I do not have a laminator, no. The school does have a laminator, yes. I don't know. There's a laminator down in the printing services office. I don't know if they will allow students to use it or not.
Why? Because I was going to make it. I was finally going to laminate will stick over.
All right, how about the tangent of, how about, I don't know, anybody got an angle they like?
45.
45 we like a lot. I want an angle that's not one of the special ones that we know.
65.
All right, so 50 degrees or 65 degrees.
Or both effed up.
Can you write those angles using the things that we know, like 30, 45, 60?
75.
Well, we already did 75. How about
100.
15 degrees? All right, we can use 15 degrees. How do you write 15 degrees using those fancy angles that we know? This is tangent of 45 degrees minus 30 degrees. All right, and then we look up the tangent formula. The tangent formula with a minus in the middle. We do tangent minus tangent on top, and then on bottom we do 1 plus tangent times tangent. Yeah, I know, fun one, huh? All right, so tangent minus tangent on top. So that's going to be tangent 45 degrees minus tangent 30 degrees divided by, down on the bottom we have 1 plus tangent times tangent. So tangent 45 degrees, tangent 30 degrees. So our answer is, what's the tangent of 45 degrees? 1, that's a nice one. Minus, what's the tangent of 30 degrees? Which one's 30 degrees? 5 or 6?
Tangent 5 or 6 is the square root of 3 over 3.
Which is what you said, and you're both correct. Square root of 3 over 3. And then he wasn't confident. He changed his mind, and he was thinking about it. Square root of 3 over 3. Divided by 1 plus tangent of 45 is still 1, and the tangent of 30 is still square root of 3 over 3. They did not change. No, they did not. Now, typically, we wouldn't leave our answer that way. Although, times 1, all right. Typically, we wouldn't leave our answer that way. Typically, what we would do, this is what we call a complex fraction. When you have the big fraction, then you have other little fractions. Typically, we would multiply top and bottom by 3.
And why is that again?
Just because fractions are bad enough. Complex fractions are even worse when you have a fraction and then you have other fractions inside of it. So we multiply by 3 over 3 because 3 is the common denominator. What's 3 times 1? 3 minus, what's 3 times square root of 3 over 3? Square root of 3, the 3's reduce out. And then down on bottom, the same thing happens, 3 plus square root of 3. So, on a quiz, on a test, if you write your answer like this, I will mark it correct because it is correct. But typically, we do simplify a little bit, and we write our answer that way.
We get a bonus point if we write it.
No, there's no bonus points for writing it that way. There's bonus points for doing a review that will be posted and things like that. All right, so we will continue on with this section Wednesday. I did not think we would finish this one today. This is a longer one.
We did get follow-up questions